Hey guys, it's Robotics here, and how is everyone doing? It has been a while since my last YouTube video, as I have been busy with my US trip last month. One of the highlights of my trip was definitely Maker Faire Bay Area 2019, and I have to say it was the most amazing Maker Faire I have ever been to. Unfortunately, the company behind Maker Faire has to shut down and let go of all its employees. It was really sad news among the maker community. But anyway, let's get back to today's video. In today's video, I'll be sharing my experience on programming the EV3 Colour Sensor in RobotC, and I'll show you how I use the three modes of the color sensor for different applications, namely the ambient mode, the reflected mode, and the color mode, each with their own example robot and program. Without further ado, let's get started. Now for the ambient mode of the color sensor, I built a very simple model here which resembles the automatic window blind. Okay, so this model uses a EV3 medium motor, one light sensor to read the ambient light readings, and one touch sensor for homing. Okay. Now in ambient mode, the color sensor does not shine a light source onto the object. It only receives and reads the ambient light readings. Okay. Well, let's look at how we can program the auto window blind to close the blind when it sees a bright light and opens the blind when the light is very dim. Okay, so first we'll save this program and give it a name. We'll just call it auto window blind. And before we start programming, we have to set up the motors and sensors. And we have one medium motor connected to port C, and I will give it a name and call it blind. Motor blind EV3 medium motor. As for the sensors, port 1 is connected to a light sensor, a EV3 color sensor in ambient mode, and port 2 is connected to a touch sensor, and click OK. Now before we start programming the main task, we'll have a function which I call homing. And the purpose of this function is to home the window blind before it starts the main program. To open position. Okay. We'll set the motor speed of the motor at -15 power. So what this does is it will slowly move the motor until it hits the end. Until it hits the touch sensor. So we'll just pull out the get touch value from the function library. So equals to 1. So it will keep moving until it touches the touch sensor, and then we'll stop the motor by giving it a speed of 0. Okay, then we'll sleep for 300 milliseconds, and now we'll move the motor target of the blind motor to 95 degrees. Now this is in relative angle, so it's not absolute, so remember that. Okay, and we'll wait until the motor, wait until the motor stops, and then we reset the motor encoder, and this will be our homing sequence. Okay, and now to the main task. So before we start the main task, we'll call the homing function. Okay, and now we'll start our main loop using a while true statement, open curly bracket. So here I will use an if statement, and if the color sensor's ambient reading of the light is more than 50, meaning that if it detects a very bright light more than 50, it's going to move the blind by 60 degrees at 30 power. We'll wait until the motor stops, and we'll display a line of text on the third row saying that blind is now closed. So if the color sensor detects a light that is less than 50, this is what it's going to do. So it's going to move the motor (60 degrees) at negative 30 power, means in the reverse direction, basically to open the blind. The first one is to close the blind. The if statements is to close the blind. The else statements are to open. Alright, so we'll continue and we'll wait until the motor stops, and then we'll display this line and say blind open, and we'll close the curly bracket, fix the formatting. So always remember to close all your curly brackets. Okay, compile it. Oops. Oh, this should be a semicolon. Compile again. Alright, this should be a semicolon. Fix the formats and compile. Okay, we're good now. So we wrote a very simple program for this model, telling the robot to close the blind if it detects an ambient light of more than 50, and open the blind if it detects an ambient light of less than 50. So let's see if this program works according to the program. Okay, it's doing the homing sequence, and now it's stuck. So, do you know what's wrong with the program? Alright, we'll have a look back at the program. So, looking at the original program, now, the main problem that we have here is because this is an infinite loop, and every time it detects an ambient light of more than 50, it's gonna keep moving as it goes through each loop. So as long as the reading is below 50 or more than 50, the motor is gonna keep moving in either direction, and that is the reason why the auto window blind got stuck just now. So let's have a look at the codes and see how we can improve the codes and make it work properly this time. We will still be using the same motor and sensor setup and the homing function from the previous program. Okay, now we need a way to tell the program that if the blind is already open, it shouldn't keep rotating the motor to make it open again, or if it's already closed, it shouldn't rotate the motor and make the blind to close any further. And we can do that by adding a boolean variable, okay, and I will call it blind open. This variable is used to store the state of the blind to tell whether it's open or closed. Okay, so before we start the main task, we'll call the homing function, and then we set the boolean variable and assign it to true. So in this case, true means it's open, false means it's closed. Okay, and then we'll go into our main loop using a while true statement. Okay, now, so this will check if there is too much light. Now, the following if statement will get the color sensor ambient light reading. Okay, if it's more than 50, if there is too much light and the blind is open, blind closes. Now we'll have another nested if statement. This time we'll check for the blind open, and if it is true, we'll move the motor by 60 degrees at 30 power. And now we set it, the blind open, to false, meaning that the blind is now closed, and we'll wait until the motor stops. Okay, and then we display a line of text on the third row telling that the blind is now closed. And we close the curly brackets. Else we do nothing. So if the light is more than 50 and the blind is open, it will close the blind. And if the light is more than 50 and the blind is closed, it will do nothing. Okay. Now back to the first level nested loop. So if the light sensor, the light sensor checks if there is too little light. Now, if the blind open status equals false, meaning if there is too little light and the blind is closed, the blind will now open. Okay, and we'll move motor target by 60 degrees at -30 power. Okay, and then we'll set the blind open to true, and we'll display on the screen telling the blind is now open, and we'll wait until the motor stops before continuing the next command. And now we close the curly bracket and finish the else statement by doing nothing. So, as usual, remember to close all the curly brackets. And compile it. Whoops. Seems to be something wrong here. 38, line 38. Okay, so we need one more closing curly bracket here. Fix the format and compile again. Okay, so seems like we have an extra curly bracket here, so just delete it compile again, and now we're good. Let's see if it works properly this time. Okay, homing is good. Okay, so if it sees a bright light, the window blind shuts, and if the light is dim, it opens up. So this time it's working properly. For the reflected light mode of the color sensor, I'll be using the standard tracker model from the EV3 kit instruction manual, just by adding one color sensor in the middle. Alright, everything else is standard. Okay. So to demonstrate the reflected mode of the color sensor, we are going to make the tracker robot to do line following. And first we'll save this program and give it a name. In this case, I'll just put line follower. Okay. And as usual, we'll set up the motor and sensors. Okay. For this robot, I have a left motor and a right motor. On the motor B, I will call it the left motor, and the motor C will be our right motor. As for the sensors, there is only one EV3 color sensor connected to port 1, which I will call light, and in reflected mode. We'll press OK, and OK. So we'll give some comments to this program so we know what this program does. So this program uses the reflected mode of the color sensor to make the robot follow a line. Alright, and first we'll define a threshold. And with a value of say 18. Now the threshold value might be different for everyone, and how you can get the threshold value is by recording the value of the black line added to the value of the white area and divide by 2. So for example, if your black line gives a value of 20 and your white area or the non-black line is giving you a reading of 60, so you just add both of them together and divide by 2, and that's how you get your threshold value. Okay, and now we move on to our main task. Okay, now first we'll use a clear timer command. Okay, and we'll clear the first timer since I want to make the program to run for 12 seconds using the internal timer. Okay, now we'll go into our main loop using the while statement. So while time 1, okay, the timer 1 is less than 12,000. In this case, it's 12,000 milliseconds, or equals to 12 seconds. So we'll make it run for 12 seconds. Alright, so open curly bracket, and we put an if statement. Now, if the color sensor gets a reflected value
of more than the threshold. Meaning if it sees a white area, it's going to execute this set of statements. So we'll set the motor speed of the right motor to a power of 50. Okay, and we will not move the left motor, so we will set a power of 0 for the left motor, and we'll sleep for 20 milliseconds. Okay, now this set of commands will make the robot move in one direction if it sees a white area. In this case, it's going to try to move towards the left. Okay, if or else, meaning if it sees a reflected value that is less than the threshold, in this case it will be the black line, it will execute something in the opposite. So in this case, we'll stop the right motor and give a power of 50 to the left motor. Okay, and we close the curly brackets, close this, and compile. So now we're good. So we'll download this program to the robot and see what happens.
Now, to demonstrate how you can use the color mode of the color sensor, I have built a simple color sorter using one EV3 kit. Basically, this robot consists of one EV3 large motor, which controls the movement of the arm, and one EV3 medium motor, which opens and closes the gate to allow the brakes to be dropped to the correct container. One color sensor, of course, to read and differentiate the different colored bricks, and one EV3 touch sensor to act as a homing sensor. Okay, I will just spin the robot around, so if you want to recreate this model, you can. Okay, it's a very simple construction. And basically that's about it.
So we start off the program by first giving it a name. So I will save this program and call it Color Sorter. And now we go to the motor and sensor setup. Okay, my motor A, I'll call it the gate. So this one will be the medium motor, which opens and closes the gate to let the color brake drops to the containers. And I have a motor D, which is an EV3 large motor, and I will call it arm. So this motor will control the arm to rotate from to the left or to the right. Okay, and for the sensors, I have one EV3 color sensor connected to port 3, and I call it color. And there is also one EV3 touch sensor connected to port 4, which I will call it touch. For the EV3 color sensor, remember to change this to color mode. and press OK. Now before we go into the main task of the program, there is one function which I call the homing function. So the purpose of this function is basically to allow the arm to go to the home position and reset its encoders so it knows its exact location each time the program starts. Okay, so we add one open curly bracket and just add a command to it so we know what this function does. The homing sequence is for centering the rotating arm to the middle position. Okay, so first we reset the motor encoder for the arm, and we also reset the motor encoder for the gate motor. And now we set motor speed for the arm motor at 15 power. So this line, we rotate the arm slowly until it touches the touch sensor. So the next line, we'll put wait until get touch value touch equals 1. So the motor will move until it touches the touch sensor, and then we stop it. And we wait or we sleep for 300 milliseconds, and now we move motor target for the arm motor by 90 degrees at -30 power. So this line will move the arm to the center, and again we wait until motor stop. Okay, and then we reset the motor encoder of the arm again, and that will be our homing function. Now we can move on to the main task. So in the beginning of the main task, we'll call the homing function, and now we can move into our main loop. So using a while true statement for our main loop, open curly bracket, and if the get color name color equals 2, and what it means is, if you look at the chart here, the color sensor returns a value from 0 to 7, and each value corresponds to a color. So for a value of 2, it means it detects the color blue. So in this case, the light sensor checks if it detects a blue color brick. Okay, if it does, we'll display centered big text line. The word blue on the EV3 display and play a sound file. Blue. And we sleep for 2 seconds. Before moving on to the next command, which is set motor target. So what this line does is it moves the arm motor by 90 degrees in absolute with a power of 30. So the arm swings to where the blue box is. Okay, and we wait until the motor stops before moving on to the next command. Now we set the motor target again. But this time is for the for the gate. So the gate opens to let the blue brick drop to the box. And again, we wait until the gate reaches 90 degrees before moving on to the next command. And now we close the gate. By moving it back to 0 degrees. 50 power. So what this line does is it closes the gate. We wait for it to stop before moving on to the next command. And now we set motor target and move the arm back to the original position. So this line makes the arm swings back to neutral position. And again, we wait for the arm motor to fully stop before moving on. Okay. Now that we have completed the codes for detecting the blue color brick, we have to do the same for the green color and the red color brick. So what we need to do is basically to put an else, and we can copy this chunk of codes and just paste it and change the values to 3. The value 3 means it detects the color green.
So we'll change the command to green, and we'll change the display to green, and we'll play the sound file green, and we'll change this position to 0, this one to green, gate, okay. This to green, gate 0, 50, gate closes, set motor 0, 30, swings back. Okay. We'll now do the same for red color. So we just copy this code and paste it. Okay. For red color brick is the number 5, and then we change this to red. Change this to red for the display, and the sound file we change it to red. Now for some strange reasons it just doesn't play the sound file red, even though I've put in the red sound file here. I don't really know why, but it doesn't matter. Okay. For the set motor target, we will change this value to -90 and change this to red. Okay. Change this to red. And we change this gate arm 0, 30, and have to remember to close all the curly brackets. Fix formatting. Okay. And then we'll just compile this program and download it to the EV3. Okay guys, that's it for this week's video. I hope the examples I've shown you will give you some ideas on how to program the EV3 Colour Sensor for your own projects and robots in RobotC. And if you want to find out more about other sensors and motors, do check out my other RobotC videos. And if you find my video useful and you like it, smash the like button and remember to subscribe to my channel. So I'll see you guys in the next video. Bye guys.